Okay, so in this problem here, we're given various bits of information, f at 3, g at 3, f prime at 3, g prime at 3, and all these scenarios here. But we aren't actually given f or g defined, and so we have to just think of them as general functions. And so when I have this first one, I have a function f plus a function g. When I add two functions together, I get a new function. And so this, if I want to do it, is just simply going to be f prime at 3 plus g prime at 3. And so I know that f prime at 3 is -6 plus g prime at 3 is 5. And so this would give me -1. Moving to question B. Well, here I can clearly see there's a product. And if I want my derivative, I know I'm going to take the first value derivative times the second one untouched plus the first derivative, g is derivative, the other one is untouched. I'm going to do that at 3. And so it's going to be f prime at 3, g at 3 plus g prime at 3, f at 3. Using the values that are here, I get -6 times 2 plus g prime is 5, f at 3 is 4. And so it ends up being -12 plus 20, that is 8. Continue along here, we'll do C part. It is very similar in the sense that this is a quotient rule. And so when I do the quotient rule, I do the bottom, I square it, I write it again, and now I do calculus at f prime minus g prime f. All of that is at 3. And so I know g at 3 is 2 times f prime at 3 is -6. Subtract g prime is 5 and f is 4 over g squared, so that's going to be 2 squared. So I get -12, subtract 20 is -32 over 4, which is -8. All right, and so as we keep on going here, we can work on D and E. Okay, so looking at D part now, we know that it's f minus g is on the bottom, f divided by this. So ultimately, when we do D, it's going to be a quotient rule. And so I start at the bottom, I take the first function and I square it. And I write it again, the denominator, times, now I do the derivative of the top, minus the derivative, the top, times the derivative of the bottom function. And this is all at 3. And so now I'm just going to do f at 3, which is 4, minus g at 3, which is 2, times the derivative of f at 3 is -6, minus f at 3 again is 4, minus the derivative at 3 of f is -6, and then g is 5, so it's -6 minus 5 over 4 minus 2, because f at 3 is 4, g at 3 is 2, and that is going to be squared. And so when I do it, I end up with 2 minus 6 is -12, plus 44 is 11 and 4, and this is 4, 2 squared, which is 32 over 4, which ends up being 8. And so we use the quotient rule on this messy combination of functions. Finally, we have E part here. Well, this is a product, but this is x squared as the product. And so if I'm going to find the derivative, I do the first part, 2x times g plus x squared times g prime. And so now I take my 3 and I plug it in. It's 2 times 3 times g at 3. G at 3 is 2. Plus, well, x is 3 squared times g prime is 5. So it's 6 times 2 is 12, plus 9 times 5 is 45. And so I end up with 57. And so doing these kind of problems is we actually just look at the function. We say, oh, we take the derivative of f and this derivative of f has this value. So we do algebra with these generalized functions.